Okay, let's learn about evaluating limits graphically and numerically. And first of all, let's understand what the notation is saying. So here's the deal. If I've got this funny looking thing here, what this is saying is the limit of the function f as x approaches c equals L. In other words, as my x values get really close to a designated c value, then my y values get really close to an L value. So here's an example of what we're talking about. Here's our function f. It's going to be x squared minus 3x plus 2 all over x minus 2, and we want to know what happens to this as x approaches 2. Well, you'll notice that we can't stick 2 directly in because that would give us 0 in the denominator. Fortunately, when we're talking about limits, we don't care about what happens right at that value. What we're interested in is what happens as we get close to 2. So you'll notice we have x values that progressively get closer and closer to 2 from the left and closer to 2 from the right. So let's bring up our calculator. Okay, in y equals, I've entered this function, and now I'm going to just grab y1 parentheses, and I'm going to put in 1.75, and we get 0.75. Now I'll go second enter and replace that 1.75 with 1.90, and we get 0.9. Okay, second enter, replace 1.90 with 1.99, and we get 0.99. And go second enter, replace 1.99 with 1.999, and we get 0.999. Okay, and then if I put in 2.01 or 2.001, 2.001, we get 1.001. So from the left, we're getting 0.999, and from the right we're getting 1.001. So what number is between those? Well, it looks like the limit is 1. Remember, we can't plug 2 in directly because it would be undefined there. But as x gets closer and closer to 2, y is getting closer and closer to 1. Okay, so this is an important concept to understand. The existence or non-existence of f of x at x equals c has no bearing on the existence of the limit of f of x as x approaches c. For example, let's look at this graph right here. It's a piecewise function. F of 2 is 0. See? There it is right there. But what is the limit as x approaches 2 of f of x? Well, as we travel along our curve, as x gets closer and closer to 2, f of x is at 1. So even though f of 2 is 0, the limit as x approaches 2 is 1. Okay, let's look at this example. Show that the limit as x approaches 0 of the absolute value of x over x does not exist. For a limit to exist, the limit of f of x as x approaches c from the left, that's what that little minus sign means, must equal the same thing as the limit as x approaches c from the right. That's what that little plus means. If it doesn't equal the same y value from the left as it equals from the right, then the limit doesn't exist. Okay, so let's see what's going on here. The limit as x approaches 0 of the absolute value of x, and it's approaching 0 from the left. Okay, that's down here. It's equal to -1. The limit as x approaches 0 from the right of the absolute value of x over x is over here, and that's +1. These are two different values, therefore the limit does not exist. Now, if you recall the very first example we worked, From the left, it was approaching 1, and from the right, it was approaching 1. Therefore, this limit does exist because they're both approaching 1 from the left and the right. All right, let's look at this example. We're asked to discuss the existence of the limit of 1 over x squared as x approaches 0. Well, here's a graph of it. And if I go to the table, you'll notice we can't let x equal 0. And as x gets larger and larger, it gets smaller. The y values get smaller and smaller. Now, if I let x be really, really small, say 0.01, so I'm going to go y1 of 0.001. Oh, need to put my parentheses in there, don't I? 0.001. We get a huge number, and our graph backs that up. You'll notice that as we're getting closer and closer to 0, the graph is shooting up, and so basically it doesn't matter whether we're going from the left side or the right side, it's going to positive infinity. So that's our answer. The limit as x approaches 0 of 1 over x squared is positive infinity. Okay, let's look at this. What is the limit of the sine of 1 over x as x approaches 0? Well, here's the graph, and let's zoom in. And as x gets closer to 0, it does something kind of weird, doesn't it? All right, let's zoom in again. And it turns out that as we zoom in, it just oscillates up and down, up and down. And as we get closer and closer to 0, we just get more and more oscillations. So, since it doesn't settle on any one value, it's bouncing backwards and forwards, up and down, we're going to say that this limit does not exist. Okay, so let's summarize what we've learned here. Common types of behavior associated with non-existence of a limit. If it approaches a different number from the right side of C than it approaches from the left side, the limit does not exist. If f of x increases or decreases without bound, in other words, if it goes to infinity or negative infinity, the limit does not exist. And finally, if f of x oscillates back up and down, it does not exist.